Hello, everyone, and welcome to today's webinar. My name is Amber Artrip. I'm the Vice President of Marketing here at Energy Cap. We are so excited for today's presentation on the implementation of energy monitoring and how it intersects with sustainability. Before we get into the presentation, I do want to cover a few housekeeping items. For one, this webinar is being recorded and will be available within 24 hours of the recording, and we will be emailing it to all the registrants. Also, if you have any questions throughout the webinar, feel free to send those over to us using the questions tab of the Zoom webinar platform. It's right there on the bottom bar there. So if you have any questions for us, you can chat those to us through the chat if you're experiencing any technical difficulties. With all of that, let's get into today's topic. We are so excited to have our partner from BEE Incorporations, Alessandro Bisagni, who is the founder of BEE Incorporations, here today to speak with us about implementing energy monitoring and how that intersects with sustainability. And with that, I'm going to pass it over to you, Alessandro.
Thank you, Amber. It's a pleasure to be part of the webinar. So thank you for having me. We've been a long partner of Energy Cap, and you've seen us grow into this field. So it's great to be able to present the work that we've done. For those listening that don't know who BEE is, I'll give a little bit of a background. We're a 15-year-old building engineering consultancy that specializes in sustainability across the built environment. We work across basically all building sectors, hospitality, commercial, even residential. But our biggest market sector where we have the most experience is retail, and specifically luxury retail. And that's what I'll be covering today, looking at the portfolios that we work on the retail side. And being an engineering consultancy, we came into the world of real-time monitoring a little bit indirectly, because when we first started, there really just was one major green building certification that existed in the market, which is called the LEED Green Building Certifications. For those listening in the US, I'm sure you're familiar with LEED. When I started the company in Shanghai, LEED was actually quite prominent, still is quite prominent as the leading international certification system. And we started to do a lot of work with new buildings, predominantly across Asia Pacific. The building stock of new buildings is a much larger share than the work that is looking at sustainability and energy efficiency in existing buildings. And definitely that was the case back in early 2009. So over the years, we started to build know-how in implementing sustainability from the design phase all the way through to construction. But when we started to work in retail, we had, for the first time, repeat clients that would come back to us and say, we've LEED certified 30, 40, 50 stores. What is the measurable benefit that we've seen for these stores? How much energy have we saved? What is the improvement in health and well-being? Does the staff that's working in the stores even know how we've improved? And back then we couldn't answer. We were on Excel spreadsheets, kind of calculating theoretically how much energy could be saved based on the predicted ASHRAE baseline improvements that we calculated during the design phase. And I knew there needed to be a change. And that's when we sought out partners, and we're very happy to have come across Energy Cap. And we started working together and building our own white label software called BSense that we've been operating now for over 8 years. We have close to 1,000 projects now that are ongoing and have really excelled, especially in the world of luxury retail, predominantly because of the advent of LEED and LEED certification and how that has taken hold specifically in the retail sector, because LEED is the only green building certification that has a specific category for retail. So LEED for retail, new construction, LEED for retail, interiors. So that's what I'll focus on today, and I'll use a couple of case studies to highlight exactly how we're using real-time monitoring for these types of clients and these types of portfolios. So this is one example of a luxury retailer. Unfortunately, we can't share the name, but I guarantee you all know who it is. It's a global retailer, global luxury retailer, who has made a commitment to do LEED certification, both for ID&C, so new store renovation, and then also O&M. So this is certifying the operations of the store, closing the life cycle, right, of sustainability in the life cycle of the project. And with the LEED requirements that allow for additional points to be achieved for monitoring, it allowed us the possibility to be installing energy monitors and indoor air quality monitors inside the space. So for this particular client, we've now done over 40 boutiques, 23 cities, 3 countries, and growing quite rapidly with a combination of IAQ, indoor air quality monitoring, and energy monitoring. One of the most requested features for portfolios like this, especially for retail, predominantly because of the mandatory ESG reporting that they need to do with the new EU requirements. And a lot of our luxury retailers are European clients. They need to be able to benchmark the performance of the stores. They need to be able to identify which ones are the bad performing stores, to go in and fix and find out exactly what's wrong. So document carbon footprint for reporting, but then also go in and try to find solutions and deep dive. And so that's where kind of the perfect marriage happened of requirements for LEED mixing together with government regulations that absolutely needed this reporting to take place. And I think that that's what's helped us really grow the monitoring business to what it is today. So this is just a very simple example of a group of stores in Korea and Japan where we have identified one that is particularly high in consumption compared to the rest, compared to what we'd call the benchmark. And when we dive into the analytics using the software, we immediately see that there are issues in the way that the HVAC has been designed. So despite having very small temperature fluctuations within the store, this is interior temperature, we see huge loads, total energy consumption, total electricity consumption inside the store. And when we further investigated, we found that it's an inadequately designed HVAC system that forced the staff, store staff, to use additional space heaters. So the plug load for the store was incredibly high, unnecessarily high, because of this poorly designed HVAC system. And so we were able to go back to the client and identify solutions for them for retrofit and fixing the issue. But then we also saw that there were issues in use. So we normally see that there are 2 categories of mistakes. One is inadequately designed systems or over-designed systems, and the other is predominantly bad operations. And bad operations is normally done by cleaning staff that's inside the stores during offload hours. And this was very much the case here. So if we then use the operational analyzer tool and we drill down into those kind of off hours when the store should be closed, we see that there is a significant amount of energy, especially in HVAC and in lighting, that is being used during those early store opening hours and during the closing hours. And if we do a further calculation on that, we see a huge potential for savings, up to 30% energy savings just in operational shift, right? So just in better management of the stores, that yields almost $10,000 in savings, paying for the majority of the systems that we've installed for monitoring. So this is a very powerful tool when we go back to our clients and we try to tell them exactly what is the return on investment of putting in these sensors, and it is quite immediate. And we sometimes have also funny things that we find out, not for this client, but for another one where we showed that there was a significant air conditioning load throughout the night, completely just never turned off, lights never turned off. We approached the client with the data. Client didn't believe us, said, no way, your meters are broken, the data is wrong. And so we went at night to visit the store and we walked in and the cleaning staff had been living inside the store because it was nice and comfortable. The AC was on, and they kind of popped out of everywhere. And so sometimes you never know what you're going to find when you analyze the data closely. Now, the other really powerful feature that we've built together with EnergyCap is the integration of the data with the LEED certification system. So under LEED, I mentioned briefly before, there are two primary categories of LEED certification. There's for new buildings and fit outs, which is really certifying the design and construction of a project. And then there's the other family that's called O&M, and that's certifying the operations and maintenance. In this new version of LEED that we have now, in version 4.1, the scoring is done through data, actual reported data. The platform, the online platform that USGBC uses to report that data and generate the score and issue the certification is called ARC. The website is called ARC Scoru. We can share it later in the chat. So the way that it works is we have linked the software directly to ARC. So real-time data from our sensors are being sent to ARC, and an immediate score is being generated in real time. So you actually have a live scoring fundamentally that happens of the building at any point in time. And right now we've done that with air quality, we've done it with water, and obviously we've done it with energy. So this is showing the portfolio of this particular client, where we have the energy score being from 0 to 100, with an average of 83 for the portfolio, the highest project scoring a 92, the lowest scoring 61. And we can look at how the averages change. We can then drill down into individual projects to see if any one building or any one project is dropping in certification score. By knowing this, we can then in real time, almost in real time, provide solutions, adjust the score so that when the client needs to submit for certification, they're guaranteed a higher level instead of waiting months to get the data, reporting into USGBC via ARC, and then being left with a lower score. So a very similar methodology takes place also on the indoor air quality side. We have sensors that can track the main pollutants that are required now for reporting, which is TVOC. Those are total volatile organic compounds. These are organic-based chemicals that are used in sealants, adhesives, furniture. You can find them everywhere. Not all VOCs are harmful, but a lot of VOCs that are used in construction are definitely incredibly harmful. They can cause cancers, they can cause neurological diseases. They are something that we almost can't avoid, but we absolutely don't want them to be accumulating inside spaces. So when we implement real-time monitoring for IAQ, it is very different than the objective that we have when we do a spot test with an actual machine that's highly sensitive. We go on site, we test for a period of time, usually it's an hour, and we get an idea of exactly the breakdown of all the VOCs, right? The specific names of all the chemicals that's in the air. The problem with that, it's a one-time, right? It doesn't actually show maybe what's happened before and after, and it doesn't show how VOCs accumulate. And unfortunately, that's how VOCs work. They kind of snowball inside the space, they grow. And if they grow, then they're going to, over time, impact the health, lower the immunity systems of the people that are working every day in that office, coming in, for as a store staff, or your children and going to school every day. So these are volatile. They happen instantaneously. They can go away. But if they are coming from a source that is consistently there, so bad furniture, bad paint, they can accumulate and they can cause significant damage. In retail, what we found is that packaging is a huge source of VOCs. So we see huge VOC spikes at night when deliveries come in. We see huge spikes in cleaning when the cleaning staff is not using the appropriate cleaning supplies. And that is actually potentially quite dangerous because cleaning is done normally when the HVAC system of the store is off. So with no recirculation, bad cleaning, it can accumulate. And if it accumulates to a significant degree, then during the day, there's not enough time to flush out the VOCs that have built up. And so therefore, that's where you see that accumulation. So here in this particular example of this portfolio, we have a group of projects that were particularly bad. And one in particular in China had significant VOC spikes that we believe were due to bad cleaning supplies. And so this is something that is easily addressable. Go to the client. We identify what the mistake is, and it can be readily changed, and we can see the results of that change quite quickly. The other main pollutant is outdoor pollution. So if TVOC is killing you from the inside, PM 2.5, PM 10 particulate matter is killing you from the outside. So if you have proper filtration systems, PM shouldn't really be coming in, but because you're in a store that has storefronts, door opens, pollutants come in from the outside quite easily, it can again accumulate and cause significant damage, especially in highly polluted cities in China that we've seen in the news. Obviously, this is a predominant issue in Asia. In this particular example here, the PM 2.5, so the pollutant accumulations were happening in the off-store hours. So that's why you see the peak is happening in the gray shaded area of the graph that then the store is off, and when the store is closed. When the store is open, there's a drop in PM 2.5. Why does that happen? The HVAC is off during the night, no recirculation is happening. As soon as it turns off, that is flushed out. But if we see, just like TVOC, if that accumulation happens too much, too high, then there's not enough time during the day to be able to flush out PM. And obviously it creates an issue inside the space. In this particular case, it was due to construction that was happening in the mall. So construction nearby, not properly managed, HVAC system off, all the pollutants would come right inside the store at night. We've had this situation happen many times. If we know the construction schedule of what's happening in the mall, normally what we can do is keep the HVAC on, sacrifice that additional energy consumption, but provide that positive air pressure to keep the pollutants from coming inside. And then we are guaranteed good air quality during the day. Another really interesting tool that's built within the software is the Reset Viral Index. Reset is a standard. It's another green building standard, but it's a true standard. And what I mean by that is that LEED certification is a certification system that references a lot of standard. It references ASHRAE for ventilation and energy. It references EPA for water efficiency. Reset basically didn't have anything to reference when it created an air quality standard. So it's the world's first air quality standard that defines how data should be aggregated from a sensor. What is the quality of the sensor? How do you define a good sensor versus a bad sensor? And how should software, like our software, BSense, that's accredited by Reset, how should we be able to display the data? What time intervals, right? And if there's any data drops, right? It has to have data quality, data consistency. One of the tools that they've then developed during COVID is a Reset Viral Index that calculates the likelihood of there being a virus transmission happening inside the space if virus is present. And the way that it does that is by using an algorithm that calculates virus survivability by using de facto values. So virus survivability is calculated by humidity. So ideal humidity ranges are between 40 and 60% of relative humidity. Outside of that relative humidity range, viruses love it. They survive. Okay, so if it's too dry, if it's too humid, virus survivability is very high. Health impact is really the immune system inside the space that's impacted by things like TVOC, and PM2.5. So essentially, higher and maintained exposures, these pollutants decrease human immune systems. So if there's a virus, we're likely to be able to catch it and get sick. We then have CO2. CO2 is a de facto value for virus concentration. More people inside a space, more talking, higher CO2. So again, if someone is sick and it's in the air, it presents a higher CO2. And compared, putting it together with a high survivability of a virus, immune systems that are already reduced inside a space, you have the recipe for a virus transmission happening. And that kind of optimization is represented in a percent value. So higher percent, the better optimized the space is, the lower likelihood of a virus transmission happening. And so here we can group the stores together. We see the lowest two performing stores are mainly because of air that's too dry. This is in the winter in Tianjin in Korea. It's very, very cold. We have a big problem being able to maintain relative humidity ranges between 40 and 60%. So again, virus survivability very high. And because we're looking at retail, we have high flux of people coming inside and outside the stores. So the CO2 values are elevated. So when you look at the results of this data from an ARC point of view for LEED, we see that it actually has compromised our score overall with an average of 38 and a huge variation in score from 24 all the way to 50. And that's really predominantly in this case because of TVOC, because of the prevalence of TVOC in retail stores. Now, shifting gears to a much different case study. This is for an outlet developer where we were very lucky to work on two of their outlets, one in Shanghai and one in Suzhou, where we were given the contract to monitor not just the energy, air, and water consumption of the base building, but also they entered into a very unique, certainly probably one of the first in China, tenant-landlord relationship green leases, where every single tenant inside the mall, at mandatory in their contract, must monitor their energy, water, and indoor air quality and report it back to the landlord. It's non-negotiable, built into the contract, which is really quite incredible. Monitoring, more than 160 spaces in Shanghai and over 185 individual tenants in Suzhou. On the base building side, so not looking at the tenants, we were tasked with monitoring everything. So we used a total of 95 electricity meters, over 60 air monitors strategically placed throughout the entire mall, and then 66 water meters and water quality meters, which I won't touch in this presentation so much. But that was particularly interesting because it was for the first time we used water consumption meters to also be able to detect leakages inside the mall. And that was something that we weren't expecting to happen. But again, with the data, sometimes you get things that you don't particularly expect, and the client was quite pleased. Overall, we found that in this case, because we're looking at base building, the predominant energy load was HVAC, with lighting and plug load being comparatively less. We saw issues a lot with HVAC sizing and balancing in different parts of the mall. We saw valves that weren't properly commissioned, that were causing excess energy consumption. And then certainly lighting use and leaving lights on during non-operational hours was probably one of the biggest energy draws. But because we also looked at the breakdown of the type of machines that were drawing energy consumption, like the plug loads, we were able to understand which machines inside compared to others were consuming too much energy. So for future purchasing policies, we could make recommendations on what to buy. We're down to the coffee machine and a water heater. So the overall savings that we were able to calculate, total 12% savings. This is across the entire shopping mall, with up to 15,000 US dollars across all the different types of operational use, the timelines, using that operational analyzer to be able to detect what are the offload hours that should be reduced. So fairly simple strategies. On the water side as well, so in addition to being able to detect where the largest water sources were coming from and how rainwater harvesting was happening, we were also able to detect this leakage detection. And this is because we were monitoring the pipes coming in from the city and high level in the design. And when we were looking at the energy consumption that was happening at the individual toilet levels, we saw that there was a difference between the two of kind of the water that was coming in versus what was being consumed at the faucet level, and there was a discrepancy. Because of that, we were also given alerts through the software, through Sentinel Trends, that pinged us whenever we had excessive water use. And we had a connection with the facility managers. We notified them of this, and we were able to save a tremendous amount of water and also a tremendous amount of money in our case, because water is comparatively more expensive in China. Then if we briefly look at the tenants and the comparison of tenants, the graph on the top left is looking at energy use intensity. So basically we're normalizing one single unit of energy, so kilowatt hours per square meter. So kind of removing size from the equation. And that allows us to rank tenants from the worst performing to kind of the better performing ones. And so we see, for example, tenant number 12, which has significantly bigger size, but also a significantly higher EUI, along with the tenants all in the gray and then black circles. Those are the ones that we know that are being operated inefficiently or have some sort of inefficient HVAC design, and there should be improvements because their peers are performing better. And so we can go down and say, turn this into a competition and say, how do we improve? How do your three neighbors down, a few doors down are performing much better than you. Why are you like this? And so now the tenant can engage in that conversation with the landlord and seek improvements year on year. On the left, we see how that translates into an actual LEED score should these properties want to achieve a LEED certification. So we see tenant 12 scoring the lowest points overall, and a big chunk of that is because of the low energy scores. So that was a broad overview of the type of work that we do in retail and in the intersection with monitoring. So I welcome any questions from Amber or the audience. Thank you.
That was great, Alessandro. My jaw is still on the floor from the story about the cleaning staff living in the retail site. That must have been shocking.
It was really surprising. I'm afraid I got a lot of people in trouble that night.
No, it's wild. It's a good testament to, we can't set and forget buildings, right? Like things are always going to be changing. I've heard stories of, janitors overriding, the lighting rules. And so it's just, you never know what's happening in your buildings unless you're tracking it regularly, right? So
That's
it's
right.
really, really great story. Really good insight too on indoor air quality, which is becoming more and more important. So great. Thank you for sharing all of that with us.
Pleasure.
We did get a few questions in throughout the presentation, so I will go ahead and read those for you. One is about LEED scoring and rating. So the LEED rating system is widely used in green building standards around the world. How does real-time monitoring help you achieve points for certification?
Yeah, it's a great question. So just a brief background with LEED. LEED evolves over time. So different rating system versions are released throughout the years. It started in the 90s, and the current version of LEED that we're in now is called version 4. And version 4 had a huge change in the way that the requirements were written, and it introduced the particular credits in energy for energy monitoring, ongoing commissioning through real-time energy monitoring, and then a credit under the IAQ section, the indoor environmental quality section, called enhanced air strategies, that as part of that credit also gives you a point for having an indoor air quality monitor. And that is really, that change in the rating system is what helped my business grow in this sector. Because when it first came out, clients weren't particularly asking for monitoring, definitely not at the tenant level, right? And LEED has always been a really great tool to justify market change, to be a catalyst, right? A catalyst for change of what is best practice. And introducing and tying that to the incentive of a point, right, makes a considerable difference. And so I was able to go back to our clients and say, hey, look, if you install an energy monitor, you can get up to 5 additional points. You can get up to a couple of additional points for indoor air quality monitoring. And that was an easy sell. Then in the past couple of years, we saw the release of LEED version 4.1, which is kind of a small step up to the version 4, but specifically in the O&M space. So in that category of operations and maintenance, now the way to certify, the way that you actually achieve LEED certification is through data only. And so obviously that was a huge push for us to be able to install monitors. And that's why we worked really hard together with GBCI, USGBC, to link the software and have an API connection so that we can provide real-time scoring.
That's great. I have an additional question for you off the top of my head, which is, if you need the data, does utility bill data work? And just you get less points and you get more points for having that real-time data? Or how does that work for some of the folks out there wondering?
Yeah, that's a good question. Yes, you can do both. So the option 1 is to take utility bills and upload the utility bills through the ARC software and type in what the totals are. You do have the same amount, so it's not less points because again, it's based on data. You're scored based on your data. But when you do that, you're not doing it in real time. So if you need to find a solution to something, you're going to be too late. And the way that the ARC scoring works in O&M, in order to certify, you need the average of the previous 12 months. So you need 12 months of data. You are scored every time you submit something. So let's say it's January, I submit my utility bill, I'll be scored for January. I'll have a January score. February, I'll have a February score, and so forth, right? But I can't actually submit for certification until I have the December data. With real-time monitoring, if I see that there's an issue, I can address it. So I'm not waiting until December to find out if my average doesn't meet.
That's right. Much more efficient with real-time data. That's great. Okay, back to the questions here. Another question about LEED. So we'll stick on the LEED topic here. What does the future hold for LEED? And will real-time monitoring play a key role moving forward?
Yeah, I think that, the previous CEO of USGBC said, data is the new natural resource. I think that's a common phrase that people say now. Yeah, data is here to stay. I think that probably one of the biggest criticisms that people have had, like the industry has had with LEED in the past, is that you can build the greenest building in the world, you can design the greenest building in the world, but then if occupants don't operate it in a green way, it's basically useless. And then also in the industry, I believe, actually, I think outside, okay, of the design and construction industry, there is a disconnect between how do buildings actually connect to climate change, right? They're not understanding how, a badly designed building puts more pressure, more load on the energy system. And so therefore you need to have more coal fire plants to produce more energy, and it's a positive feedback loop. And so LEED is now coming up with the newest version of its rating system called LEED version 5, but is very much targeted at decarbonization, data, and then impact at scale, right? So they're trying to balance out how am I going to have people understand that buildings contribute to climate change? We need to push the needle, right? And we need to make it stringent, but we need to be able to also target, grade B, grade C buildings. We can't just be in the grade A category. And so the first pilot that they launched for LEED version 5 is an O&M category. And as part of that, there's an interesting addition that gives you points in O&M just for having the monitors. So just by putting in an energy monitor or putting in an air monitor, you're already scoring points. Then if you meet the thresholds and you have scores, then you have additional points. And I think that is a really, really smart way to do it, because maybe people are too scared. They don't want to display the data. They don't know what it's going to be, right? And we have that issue quite a lot, right? They don't want to, especially with air quality, they don't want to submit the air quality scores because they're afraid the results are going to be bad. So they just don't monitor. I mean, I would rather that a client monitors, keeps the data to themselves, tries to improve quietly, but is still achieving a LEED certification. So I think it's a smart move in terms of market change.
Yeah, it's a really good point. I never thought of it that way, that they don't want to install monitors because they are afraid that it might hurt their score. So I think that is a great tactic to get more people involved in this real-time monitoring. So that's great. Thanks for sharing. We have a few more questions here that I think we can tackle in the amount of time we have. So next question is, what is the WELL building standard, and how does real-time monitoring fit into the rating system?
Sure. So without going into a whole other description of another rating system, you can consider WELL as the sister certification of LEED. If LEED is for buildings and energy efficiency and the more traditional concepts of sustainability, WELL is about the people inside the buildings and the health and well-being. So there's an overlap between the two. There's actually a formal crosswalk between the two certifications, so that if you're doing one, there's certain requirements you don't have to document again for the other. But fundamentally, they're looking at different things. An example in the lighting category would be that LEED looks at saving energy in lighting, so making sure your lights are energy efficient. On the WELL side, it's looking at the color of the light and how the color of the light impacts our circadian rhythm and impacts our alertness and our production of melatonin to be relaxed. So that's a kind of a good example. Monitoring comes in right now predominantly indoor air quality. Air quality has a huge, I can imagine, an entire concept, an entire section dedicated to it. And being able to monitor in real time indoor air quality coupled together with spot testing is able to get you points in the system.
That's great. Yeah, I think more emphasis on the health of our buildings that we live in, work in, play in. We're in buildings all the time, and you never really think about how healthy is this building. So it's great that WELL is there to let us know. Next question, what key challenges does real-time monitoring solve for those interested in pursuing a WELL certification project?
Okay, so right now, the honest answer is not so much beyond the ability to get points in indoor air quality, but I think that is going to change. The one key difference with WELL as opposed to a lot of other rating systems is that it requires an on-site test. And so that is the biggest challenge of achieving well, period. So in addition to the documentation work that we do as consultants to put together to prove, right, to GBCI that a project conforms, there's also the requirement of having a verified performance testing agent that goes on site and does spot tests for air quality, sound quality, light, and thermal comfort. That is very expensive. That is one of the biggest barriers for people to do well, because you have to pay the consultant, you have to pay the fees to IWBI, and you have to pay the performance testing agent fees. I believe, and I know this because I'm on the air working group for IWBI, as technology develops, as sensor technology gets better, there will be a reduction in the requirements of performance testing agents to do spot tests that can be taken over by real-time monitors. We see that already happening in the airspace, where monitors are quite well developed. I think light is going to probably be next, with having, lux sensors are easy to get. Circadian sensors a little bit more tricky, but they are available. Water quality, we've already started doing it, as in the example that I showed in VRC, but it's still at a very early level. It's nowhere near the detection that we do when we do an on-site test. That sound is possible, right? Sound, or at least decibel levels, maybe not reverberation. So there's a big space. If anybody is out there that's a hardware vendor, and I strongly recommend that you look at the requirements for testing in the well building standard, because I think that there's quite a lot to be done.
Yeah, that's really interesting and really exciting. The less, physical presence we need for that is great. All right, we've made it to our last question. Are there any other green building rating systems that listeners need to be on the lookout for that will have a strong impact on the real-time market?
I think Reset, that I mentioned before, they have been growing. They are now referenced in LEED version 5. They're referenced in WELL. For anybody listening in the UK, they're referenced by BRE for the BREEAM system. And they're growing in their modules. So they're not just looking at air now, they also have a standard for energy. They have a standard for embodied carbon. And they're data-based, they're sensor-based and data-based. So I'd say definitely be on the lookout for them. In the building space, now ESG is the hot top. Everybody's talking about ESG and the new reporting requirements that are coming online. So us as a company, that has also shifted our client base from being just developers and tenants to now financial institutions and REITs that own portfolios of thousands of buildings. Most of them are not grade A buildings. They need to now, because of regulations, ESG a lot of them are public companies that have to report on their carbon footprints. How do they do it? They're doing it on Excel. They're collecting utility bills on Excel. It's incredibly time consuming and inaccurate. So there's a tremendous opportunity for EU taxonomy reporting, GRESB reporting, and the 100 other ESG reporting tools that there are.
That's right. I think that's the next big thing, right? Indoor air quality and keeping us healthy in the buildings that we live in is really important. So that is all the questions we have for today. Thank you so much, Alessandro, for the presentation and the conversation and answering all of our questions. It was great. If anyone's watching and is interested in reaching out to BEE, what is the best way for them to get a hold of you?
Oh, you can go on our website, www.bee-inc.com, and just click the contact us button. That's the easiest.
Perfect. We will send out a link to the website as well with the recording and publish it as well on our website once it's live. And also, if you want to learn more about Energy Cap, you can visit energycap.com to learn more about us and what we do. Thank you again, Alessandro. Thank you for being an amazing partner and sharing all of your great stories with us. We are super fired up about the work you're doing. It's really important. So thank you and have a great day, everyone.
Thank you. Bye-bye.